Next time you wipe with a paper towel, think of Albert Einstein. The German scientist is not credited for inventing paper towels, but he did carry out research on wicking, which is just a fancy word for the phenomenon that allows towels to soak up liquids against the force of gravity, pushing the liquid downwards. What type of world would we be living in if Albert Einstein did not exist? Well, it is safe to assume that if Albert Einstein had not existed, his contributions to science might have been discovered by other scientists, but at a later time. He revolutionized science because he was coming up with theories and discoveries well ahead of his time, while other scientists still believed that E equals mc squared was still a myth. He published works that proved otherwise. Born in in Germany, Albert Einstein was a little different from the other children. He was an introvert as a child, with a head which was slightly larger than the norm. At his new school in Munich, he showed an aptitude for mathematics, especially geometry and calculus. Who knew a kid could like math so much? Outside the classroom, his friend Max Tollman, who was a medical student, helped him to explore a separate path of learning. They studied philosophy and mathematics. His family moved to Pavia, Italy after his father's business failed. He was only 16 when he came up with Einstein's mirror while staring at, as you can guess, a mirror. Renouncing his German citizenship in 1896 to avoid military service, he gained Swiss citizenship, which he never revoked. Despite being generally acknowledged as a genius, he was unable to find a teaching post after graduation. He then began evaluating patent applications for electromagnetic devices in Bern. While still working in the patent office, he completed his PhD at the age of 26 and had more than 4 important papers published in a leading German journal. During his time working at the University of Bern, University of Zurich, and the University of Prague, he kept publishing papers. At this time, most of his work was controversial and challenging stereotypes. This did not go down well with the science community. His general theory of relativity was not widely accepted until a British astronomer, Arthur Eddington, claimed to have confirmed it in 1919. From then on, it was accepted as probably the greatest scientific discovery ever made. His award of the 1921 Nobel Prize in Physics for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect, was not in recognition of his work in the theory of relativity. Without Albert Einstein's contribution to science, fundamental theories about light, gravity, motion, mass, and energy would have most likely been discovered years later. Human progress in these fields got a boost from his findings. Take, for instance, the quantum theory of light made it possible for the invention of modern-day television. This quantum theory of light also serves as a foundation for space exploration. The photoelectric effect, which he received a Nobel Prize in Physics, was to explain the process of emission of electrons from metals that are struck by lightning. Imagine the number of people whose lives were changed by the simple fact that they could watch important events taking place and not just hear them. In 1905, the world and the field of physics were changed by his laws of relativity. The first law of relativity is the theory of special relativity. Einstein discovered that the laws of physics are the same for all non-accelerating observers and that the speed of light in a vacuum was independent of the motion of all observers. This theory only applies where nothing changes the nature of motion in any way. An increase in speed or a bend in the road has to be explained by the law of general relativity. Einstein changed the generally accepted concepts of mass and energy, which were as completely separate. He was able to prove that the principles of conservation of mass and conservation of energy are part of the same, larger, unifying principle, which is the conservation of mass energy. Hence the equation E equals mc squared. It is possible to turn matter into energy and energy into matter because a fundamental connection exists between the two. World War II would have turned out differently if he never wrote letters to US President warning him about German scientists who successfully split the uranium atom using nuclear fission. The reaction that followed was capable of creating a massive bomb because of how powerful it was. Worried at the destruction capability of this discovery, Einstein wrote several letters to President Roosevelt that would lead to the creation of the Manhattan Project 2 years later. It would be incorrect to say his equation created the nuclear bomb, but instead, the formula E equals mc squared showed that it was possible to create one. Quantum physics also benefited from his contribution, the photoelectric effect, even though in later years he showed disdain for it. Space exploration relies heavily on quantum mechanics, and who knows if all man has achieved in space would be possible without the contributions of this genius. The commercialization of solar power can be linked to Einstein also. Although he did not invent them, he sketched out their basic principle of operation. Key understanding of the photoelectric effect made this possible. Even though it cannot be said that science would not have progressed without his discoveries, it would have been moved at a much slower pace if he did not exist. I hope you learned something new today. If you still have some questions left, let us know in the comment section below.